Okay, welcome to the SPSS 3 lecture. So we're going to be using the same data set as we used before for the rest of the SPSS lectures. So go ahead and log on to Canvas and go to Files. And once you're in Files, go to Week 1, SPSS Lecture 1. And you're going to see this data example.save. So that's going to be your data file. Okay, so now go back to Files. You can just click here. And then go to Week 4, SPSS Lecture 3. And then go ahead and click on SPSS Lecture 3. You'll notice there's SPSS Lecture 3 key. That is basically the answer key or the notes that I'm going over right now. But go ahead and download this file, SPSS Lecture 3, so you can go ahead and follow along. Okay, so let me find those files. Give me 1 second. Okay. Oops. Here it is. Okay, so the document says identify outliers based on the z-score definition. Okay, and it looks like, so something I don't have here that I'm going to add, it's in my notes. We're going to use neuroticism underscored mean in the data set. So that's fine. So let's go ahead and do that. So let's go ahead and find the data set. And once we're in the data set, let's go ahead and find this neuroticism mean variable. Okay, so variable and neuroticism. Perfect, so there it is. Now, if you want, you could take this variable, and you should be able to, oh, it's not letting us. That's okay, we'll just leave it right there. Nothing wrong with that. Okay, so now go to Analyze, Descriptive Statistics, Descriptives. Okay, and you can go ahead and right-click and say Display Variable Names. And then scroll down, it's all the way over here, Neuroticism Mean. Okay, move it over. Then go to, actually you don't need options, you need this button right here. It says Save Standardized Values as Variables. So go ahead and click on that. Once again, let's go ahead and do some screenshots while we're at it. So if you're using a Mac, you could just do Command-Shift-4 and it'll take a screenshot. If you're using a PC, you can go ahead and use snipping tools. Okay, so just go ahead and press OK. So it's going to give us some output that we don't care about. So go ahead and minimize that. It's not a big deal. And I'm going to go ahead and copy the screenshot and paste it in my document. Okay, perfect. So this is how we identify z-scores. So let's go back to SPSS. And now let's go to the data view and scroll all the way to the end. And you'll see this Z neuroticism mean. Okay, so let's go ahead and grab this neuroticism variable and I'm just left clicking and pulling it. Oops, interesting. Okay, hold on. Perfect. So I just moved the neuroticism mean raw score variable next to the z-score variable. So what I would do now is just right click and sort ascending. And that is not sorted ascending. Okay. So it looks like SPSS is a little buggy when it comes to sorting. And again, I'm using a Mac, so if you're using a PC, it might work better for you. There you go. So it eventually worked. Just right-click, sort ascending. Okay, so recall the z-score definition for identifying outliers. Basically, any raw scores that have a z-score of -3 or lower, or a z-score of +3 or higher are considered outliers. So obviously on the lower end, our lowest negative value is a -2.36. So we don't have any outliers on the negative end. So let's go ahead and sort descending. And as well on the positive end, our highest positive z-score is a 2.52. Okay, so obviously we don't have any outliers. But let's say we had a score, a raw score that had a z-score of 5. Well, 5 would be higher than +3, therefore it would be considered an outlier. Again, if we had a raw score that had a z-score of -4, that raw score would be an outlier because its corresponding negative z-score is below -3. So let's go ahead and just add those words to our file. Okay. I'm going to zoom in a little for us. Okay, so something like this will suffice. So scores that are +3 standard deviation units or above, or -3 standard deviation units or below, are considered outliers. Based on this definition, there are no outliers in the neuroticism distribution. Question 2. What outliers are identified by the IQR definition that are not identified by the z-score definition? So once again, we're going to use the neuroticism mean. Let me add that down there. Okay. Okay, so a couple weeks ago when we did SPSS Lecture 2, we actually calculated the interquartile range for the neuroticism mean we calculated. So let's go ahead and head back to Canvas and pull up that answer key. Okay, so once again we're in Files, week 2. Okay. SPSS Lecture, SPSS Lecture key. Let's go ahead and just download that. Okay, so we did it. Let's see. Okay, identify outliers based on the IQR definition. So we use the neuroticism mean we calculated. Okay, so just go ahead and copy and paste this. This is fine. Over here. Here, I'm just going to change this up a little bit. Okay, so that's going to be our answer. So Basically, this is saying any raw score values that are 4.92 or higher, or 0.79 or 0.8 rather, and lower are considered outliers based on the IQR definition of outliers. So to figure this out, we could just go back to our SPSS file and find our neuroticism mean, which is right here. Okay, we could just sort ascending. Okay, so as you can see, the lowest possible value is a 1.13. Okay, so there's nothing that's 0.8 or lower. Oops, let me go ahead and close this. Let's go back to SPSS, and we'll sort the other direction. So descending. And our highest possible value is a 4.75. Okay. So let me just write a little bit of an interpretation. Okay, so what's going on here is that according to the z-score definition, right here, and according to the IQR definition, there are no outliers. Because the definitions for identifying outliers here are slightly different, it is very possible that one definition will identify outliers that the other definition doesn't identify. So it is possible, and again, it's like anything, right? You change the definition, you're going to change the answer that you get. Okay, so let's go ahead and look at item 3. Identify the self-esteem variable, RSES mean, the neuroticism variable, neuroticism underscore mean, and the openness variable, openness mean. Create scatter plots for each pair, and predict the size and direction of each relationship. Okay, so let's go to our data. Okay, and in order to create a scatter plot, we need to go to Graphs, Legacy Dialogues, Scatterplot, and just go ahead, and what I'll do is I'll take a little snapshot here. It's just going to be a simple scatter, and we're going to define it. We're going to, for our first one, we can go ahead and find self-esteem. So let's find RSES mean, and we're going to make that our, put that on our y-axis, and then we're going to find our openness mean and put that on our x-axis. Okay, we can take a little snip of this. It's always good, you know, when you're working in SPSS, to take little snippets just so you remember what you did. Hit OK. Okay. And as you can see, here's a nice little scatter plot. So you can either copy it or you could just take a snip of it. I'm just going to take a snip of it because sometimes on my Mac I have issues copying in SPSS. So I don't know if it's a lack of knowledge on my part or it's actually slightly buggy. Okay. So let me grab a couple of the scatter plots that I did. Here's, the screenshots. So here's one. I'm going to start a new page. Okay, perfect. So that's how we started getting our scatter plot. This is how we inputted the variables right here. So these are kind of big, so I'm going to make them smaller. Okay. I think it tilted over itself. Okay, that's a mess. Okay, and then here's the actual scatter plot. Yeah, that's good. Okay, so remember when we talked about scatterplots in our by hand lecture. So essentially, there's going to be a line going through these points from the lower left to the upper right. So because the line is slanted in that direction, it's easy for us to understand that there is a positive relationship between these two variables. And of course, the closer the dots get to the line, the bigger the correlation is. So a perfect positive correlation, so r equals +1, all of the dots would be on the line. And as the correlation approaches 0, the dots are going to become more spread out. So I'm going to write out a little interpretation that I came up by looking at this. Okay, so this is the interpretation that I wrote. So basically, looking at the scatter plot, I believe there's a positive correlation between high self-esteem I believe there's a positive correlation between self-esteem and openness, because it seems that high openness scores tend to be associated with high self-esteem scores, and low openness scores tend to be associated with low self-esteem scores. Based on the spread of the data points, it appears that the correlation will be approximately plus 0.3. Okay, so like I said, if it's a perfect positive correlation, it's going to be +1. This is kind of like, based on my experience and the spread of these data, I feel like it's a 0.3. But again, this is just an estimation. We calculate the real correlation to actually know the right answer. Okay. Let's go ahead and create a scatter plot for the relationship between neuroticism and self-esteem. Okay, so once again, we're gonna go back to SPSS. We're gonna go to graphs, legacy dialogues, Scatterplot, simple scatter. Okay, we're gonna go ahead and leave self-esteem on the y-axis and put neuroticism on the x-axis. So let's go ahead and get that picture. So once again, I'm just gonna snip it. Okay, perfect. Just going to put this on its own page. I'm going to borrow this interpretation, just change some of the words. So as you can see, this is going to be a negative relationship because if you draw a line through the points, you know, based on what you think the slant's going to be, it seems like you would draw a line from the upper left to the lower right, which if the line is slanting in that direction, you know that that represents a negative correlation. Now, as far as the extent of the correlation, it actually seems like it is, you know, around the same amount. It looks like in my notes I put a negative 0.4. Maybe I changed it to 0.4 just to, you know, have some sort of different answer, but it's hard to know, right? So it's going to be around a negative 0.3, negative 0.4, I think. Okay, so I believe there is a negative correlation between self-esteem and neuroticism because it seems that high neuroticism tends to be associated with low self-esteem, and low neuroticism scores tend to be associated with high self-esteem scores. Based on the spread of the data, it appears that the correlation will be approximately negative 0.3 or negative 0.4. Okay? Cool. So now let's do another scatter plot, but let's keep neuroticism on the x-axis and put openness on the y-axis. Okay, so go back to SPSS. We're going to go to graphs, legacy dialogues, scatterplot, simple scatter. Okay, so we're leaving neuroticism on the x-axis. We're going to put openness on the y-axis. Okay, let's do it. Wow, this kind of looks like there's nothing going on here, right? Okay. So you might be able to predict a slight negative correlation. Yeah, and that's actually what I have in my notes, so that's good. There is a very slight negative correlation between openness and neuroticism because it seems that high neuroticism so in my notes I say I believe there's a very slight negative correlation between openness and neuroticism. Or there is no relationship. Okay, so you could totally see that potentially there's no relationship. And in fact, when I first saw it, that was my comment. Okay. So Okay, so the argument for a very slight negative correlation, it seems that high neuroticism tends to be associated with low openness scores, and low neuroticism scores tend to be associated with high openness scores. Okay. Based on the spread of the data points, it appears that the correlation will be approximately, I would call it negative 0.1 or 0. 0 meaning there's no relationship between these variables. Okay, cool. So again, the scatter plot, is a nice way to, plot the relationship between two variables. And based on the scatter plot, you can predict the magnitude or size of the correlation as well as the direction of the correlation. So that's why it's useful. Okay, now we're going to go ahead and we're going to calculate some correlations here. So we're just going to find a correlation between self-esteem and neuroticism, self-esteem and openness, and neuroticism and openness. Okay, so once again, go back to SPSS, go to Analyze, Correlate, Bivariate. Oh, and I already have them in there, but I'll show you how to do that. So just scroll to the end of the list and you'll find self-esteem, you'll find neuroticism, you'll find openness, and that's good. One additional thing you can do is, if you go to options, you can add means and standard deviations for each variable, but that's not really necessary for what we're trying to do right now. So let's just go ahead and do it. And here you go. Here's our correlation table. I'm going to take a snapshot. Okay, and our Word file. Okay, so how do you read this in SPSS? There seems like there's a lot going on, but there's really not. So here's self-esteem correlated with self-esteem. When you correlate a variable with itself, it has a perfect correlation, right? 1. There you go. So that's useless. Obviously, we're not going to look at that. Now let's correlate self-esteem and neuroticism. We're getting a negative 0.475. Okay. The p-value, so significance two-tailed, so this is our p-value, is less than 0.05, and n equals 251. That means there's 251 participants that have a self-esteem score and a neuroticism score. Therefore, we could calculate the relationship between the two. So it's the same thing here, and it's the same thing on these other sides. So truly, all we're interested in here, we're interested in the relationship between neuroticism and self-esteem, as well as openness and self-esteem, and then neuroticism and openness. So 1, 2, 3. So let's go ahead and do our interpretations right now. So let's go ahead and start by discussing the relationship between self-esteem and neuroticism. So the relationship between self-esteem and neuroticism is a negative 0.475. Okay, so I'll just put this in writing. So regarding magnitude or size of the correlation, remember that I'm looking for the plus or minus symbol. Usually it just appears. Yeah, I'll find it later and I'll put it in my notes online. But basically plus, we'll do plus slash minus. So plus or minus 0.01 is going to be a small correlation. Plus or minus 0.03 is going to be considered a medium correlation. Plus or minus 0.5 is going to be a large correlation. Okay. So let's continue with our interpretation. There's a medium to large negative relationship between self-esteem and neuroticism, such that high self-esteem tends to be associated with low neuroticism and low self-esteem tends to be associated with high neuroticism. Okay, that's good. So that's the interpretation for the correlation between self-esteem and neuroticism. So we could do the same thing for self-esteem and openness. Oops. So R is equal to, so self-esteem and openness, 0.32. We can go ahead and round that to 0.48. Okay, I'm just going to steal this verbiage and I'm going to alter it a little bit for this interpretation. Okay, so there is a medium, positive relationship between self-esteem and openness, such that high self-esteem tends to be associated with high openness, and low self-esteem tends to be associated with low openness. And in my notes, I'm saying openness scores, self-esteem scores, neuroticism scores, but you know, you could leave that out. Okay, let's interpret the last relationship. The last relationship is the relationship between neuroticism and openness. Okay. R equals negative 0.27. So we could say there is a small to medium negative relationship between neuroticism and openness, such that high neuroticism tends to be associated with low openness, and low neuroticism tends to be associated with high openness. Okay, perfect. So the next thing that we need to do is we need to create regression equations for self-esteem predicting neuroticism, self-esteem predicting openness, and neuroticism predicting openness. Okay, and then we need to interpret all of those regression equations. So let's go ahead and do that. So to do that, we need to go to SPSS. We need to go to Analyze, Regression, Linear. Okay. So let's look at the wording. It says self-esteem predicting neuroticism. So because neuroticism is being predicted, it is considered the dependent variable. So neuroticism, because it's being predicted, will go up here. And self-esteem is doing the predicting. Okay. And I think that's all we need to do. You know, as you click around SPSS, there's a lot of different functions within functions. So I'll just go ahead and snip that and press OK. And what's important to take out of this is the coefficients. So I'll go ahead and snip that as well. Okay, let me move this over and find my screenshots. I believe this is one of them. Okay, perfect. So here we have it. Okay, so you could go to symbols and you can find Y with a little hat over it, which I did for the official notes that I'm posting. But for now, I'm just going to write Y dash hat, and you could do the same. Y with a hat over it means Y being predicted by X. So Y hat equals the B, a constant, is going to be our Y-intercept. Okay, and the B RSES underscore mean is going to be our slope. Okay, so there you go. That's our little regression equation. If you need a little refresher, go back to the regression lecture. Okay, let's write a little interpretation here. When X, that is self-esteem score, Okay, there you go. And so when x, which is the self-esteem score, is 0, then y hat, or the predicted neuroticism score, is going to be 5.125. Okay, and for every 1 unit increase in x, y hat decreases because it's negative by 0.708 units. So one other thing that's important to know regarding regression is this. So once you have your regression equation, you can predict y hat scores or neuroticism scores from self-esteem scores or x scores. So for example, okay, so for example, if a participant has a self-esteem score of 5, so you could just substitute 5 for x, okay, it is predicted that he or she will have a neuroticism score of 1.585. So literally 0.708 multiplied by 5, and then subtract that from 5.125, and you should get 1.585. Okay. So we just did self-esteem predicting neuroticism. Now let's do self-esteem predicting openness. Okay, I'll write this out. So now we're doing self-esteem predicting openness. Okay, perfect. So just go back to SPSS, go to Analyze, Regression, Linear. So now we're predicting openness, not neuroticism, from self-esteem. So just add openness, hit OK. And then all you're interested in is this coefficients table. Perfect. So what you can do is just borrow from what you did above, saves time. Just change the numbers around. So once again, the y-intercept here is going to be b constant, so 2.548. The slope is going to be positive 0.377. When x, which is self-esteem, is 0, y hat, or the predicted openness score, is going to be 2.548. And for every 1 unit increase in x, y hat increases because it's positive. .377 units. Okay, good. I think we're getting the hang of this. So the last one is neuroticism predicting openness. Okay, neuroticism predicting openness. So let's go ahead and go back to SPSS, and we're going to go to Analyze, Regression, Linear. Okay, self-esteem is now gone, and neuroticism is going to be predicting openness. So go ahead and hit OK. And again, we're interested in this coefficients table, so go ahead and take a snap of that. It should appear. Is it this one? No, that doesn't look to be the right one. I think it's this one. No, not that one either. Yeah, this is the right one. Okay, once again, I'm going to borrow this verbiage and just write it. So y hat equals this constant, which is the y-intercept, 4.349. Okay, and the slope is negative 0.209x. When x, or self-esteem, is 0, then y hat, when x, which is actually neuroticism now, equals 0, then y hat, which is the predicted openness score, is going to be equal to 4.349. For every 1 unit increase in x, y hat, it's going to decrease because it's negative. Y hat decreases 0.209 units. Okay. So that's all we have to do with regression. Okay, now we're going to move into the land of inferential statistics. So we actually don't have to do another analysis for this because when you calculate a correlation, the inferential statistics is built in. Or rather, are built in. Okay. And what it comes down to is the p-value. Okay, so significant two-tailed, 0.000 is 0.000 less than 0.05. Oh, it is? Okay, the correlation between self-esteem and neuroticism is significant. Therefore, reject the null hypothesis. P is less than 0.05. Okay, same here. It looks like all of our p-values are less than 0.05. So all of these relationships are significantly different from the population correlation of 0. Okay. So let's look at self-esteem. And openness. Okay, so the null hypothesis is going to be rho equals 0. There is no relationship between self-esteem and openness in the population. Retained as one among many hypotheses that these data support. Okay, and then we have our alternative hypothesis rho does not equal 0. Rho does not equal 0. There is a relationship between self-esteem and openness in the population. Okay, so obviously we found that P is less than 0.05 or 5%, right? So we're going to reject the null hypothesis. So because we're rejecting the null hypothesis, we're going to interpret the alternative hypothesis, and we're going to say so technically you can jump to what I just wrote, or you can actually start with the alternative hypothesis. And you could say there's a relationship between self-esteem and openness in the population, and then you can say specifically there is a significant positive relationship between self-esteem and openness in the population. Okay, so here's the second part of the interpretation. The probability of the sample data obtained. So getting the sample correlation that you got, if the null hypothesis is true, the null hypothesis is true means rho is 0, is less than 5%. Because of this low probability, it is not likely that the population from which the sample data was drawn is the population specified by the null hypothesis. And again, the null hypothesis is a population where rho equals 0. Okay, so for more details about what this actually means, go ahead and watch my t-test to test the difference between row and zero lecture, as well as my one sample t-test lecture. One thing I wanted to also show you is this. Okay, so what if p is greater than 0.05? Okay, so this is our what if scenario. And I'm going to show you how the verbiage changes. What if p is greater than 0.05? Okay. I'm going to make this a little smaller. Okay, perfect. So if p is greater than 0.05, we would retain the null hypothesis. Okay. We would retain the null hypothesis, therefore we would interpret the null hypothesis. So we would say there is no relationship between self-esteem and openness in the population. Retain is one among many hypotheses that these data support. Specifically, there is not, and that's key, not a significant positive relationship between self-esteem and openness in the population. The probability of the sample data obtained, if the null hypothesis is true, is greater than 5%. Because of this large probability, it is likely that the population from which the sample data was drawn is the population specified by the null hypothesis. Okay, perfect. So now, let's look at the relationship between self-esteem and neuroticism. Okay, so the null hypothesis is going to say rho equals 0. There's no relationship between self-esteem and neuroticism in the population. Retain as one among many hypotheses that these data support. The alternative hypothesis would say rho does not equal 0. There's a relationship between self-esteem and neuroticism in the population. Okay. So what we found, again, so self-esteem and openness, we found that p is less than 0.05. Oh, sorry, we're looking at self-esteem and neuroticism. P is still less than 0.05. So P is less than 0.05 or 5%, therefore we're going to reject the null hypothesis. So we're going to interpret the alternative hypothesis, and we're going to say there's a relationship between self-esteem and neuroticism in the population. Specifically, there is a, well, what direction is it? To figure out the direction, we go back to our sample correlation, and the sample correlation is a negative 0.475. So we're going to say, specifically, there's a significant negative relationship between self-esteem and neuroticism in the population. The probability of the sample data obtained, well, the sample data was negative 0.475. If the null hypothesis is true, is less than 5%, because of this low or small probability, it is not likely that the population from which the sample data was drawn is the population specified by the null hypothesis. Okay, so remember, this is the reasoning behind our interpretation. Okay, so we have one more relationship to discuss. The relationship between openness and neuroticism. Okay, perfect. So once again, we have our null hypothesis, rho equals 0. There's no relationship between openness and neuroticism in the population, retained as one among many hypotheses that these data support. The alternative hypothesis is rho does not equal 0. There's a relationship between openness and neuroticism in the population. Okay, so openness and neuroticism is going to be here. So P is less than 0.05. Okay, so once again, P is less than 0.05 or 5%. Therefore, reject the null hypothesis. There's a relationship between openness and neuroticism in the population. Specifically, there's a significant, well, is it negative or positive? Let's go back and check. Neuroticism and openness, it's a negative relationship. Okay, specifically, there's a significant negative relationship between openness and neuroticism in the population. The probability of the sample data, well, what's the sample data? Neuroticism and negative 0.268. Okay, if the null hypothesis is true, is less than 5%, because of this low probability or small probability, it is not likely that the population from which the sample data was drawn is the population specified by the null hypothesis. Okay. Well, it looks like we sufficiently answered all of the questions. Once again, if you're still having some trouble with this interpretation, well, whether it's the correlation, regression, or t-test to test the difference between rho and 0 interpretation, go ahead and look at the t-test to test the difference between rho and 0 lecture, the one sample t-test lecture, and the correlation lecture. Those are all going to help you out, and I give a more detailed explanation in those by hand lectures. Okay, good. So we're done. Congratulations, you made it through SPSS Lecture 3. Let's go ahead and pray. Dear Heavenly Father, thank you so much for this day, Lord. Thank you for giving us the strength to show up, for me to record this video, for the students to have the will and strength to pay attention, to learn, and be able to reproduce this. Lord, we're surely blessed to be alive every day, to be called to you. Lord, give us the wisdom to understand how what we just learned is related to how you're calling us, to how we are called to live out the Great Commission. Thank you, Father. In Jesus' name we pray. Amen.